Okay. Woohoo! Yeah. Is this what I speak into?
Should be on.
Test? Oh,
Yeah.
This is working.
Yeah, it is. You don't need it?
No, I can use it. I don't know if you introduce me or...
Okay.
I can.
Sure. Yeah.
I'm ready.
And good afternoon. Good afternoon, everyone. Thanks for joining. We have Julien Vehent. He's an expert in all sorts of application security. He works with Mozilla, and he keeps the Firefox cloud services at Mozilla safe. He has also authored a book on securing DevOps, and so we look forward to hearing his interesting presentation. Welcome, Julien.
Thank you. Hi, everyone. I have never given a talk before with that kind of microphone, so I feel like a stand-up comedian. I try not to make too many jokes, but this is kind of cool. So this talk is about modern web application security. I'm going to talk about the kind of problems that we've seen at Mozilla over the years, securing websites and web services all over the place, and how you work around that and what kind of security you can put in place on your websites. So I've been introduced already, but very quickly, I run the operations security teams on Firefox. So we take care of all of the Firefox backend services, the stuff that you use to log into your Firefox account or synchronize your bookmarks or receive web push notifications. I'm a developer. I started mostly as a sysadmin, did a bunch of development. I think I'm more some sort of DevSecOps, SecDevOps, DevOpsSec, whatever you want to call it nowadays. I also authored a book that's called Securing DevOps. So we talk about DevOps a bit in the book, and we talk about security a lot. That actually covers, like, this is kind of the 400 pages version of this talk. So if you want the long version, go check this out. And with that, what I really want to focus on today is, at first, the kind of issues that we see on modern websites. And we're going to take a random target, but one that obviously will not offend anybody. And 4chan. Everybody hates 4chan. It's fantastic. It's easy to beat on it. 4chan is terrible. Not only because of the content that gets posted on there, but also because of its web security. And let me try to zoom in here a little bit. See if we can get this a little bigger. That should be fine. So this is the grading of 4chan according to observatory.mozilla.org, which is a website we run that scans your website and will give it a grade depending on various security controls that you have put in place. 4chan gets an F. And it gets an F because it doesn't have a content security policy. It doesn't have sub-resource integrity. It has no TLS at all, no HTTPS at all. It has a whole bunch of issues. And you might think, well, that's a grade, okay? So maybe it doesn't really matter. But we'll discuss later on that, yes, actually it does matter. And having a good grade will help you in your security. So 4chan, well, you wouldn't expect them to be awesome at security. After all, it's only comments and shitty content that goes on there. So let's look at some other websites. And this is United.com. All right, you would expect them to have a little higher budget for their web security, and they get a D. They have no content security policy. They have no protection on their session cookies. I think up until recently that was one of the sites that was posing problem to Firefox because they had RC4 enabled on their SSL, and that was actually prioritized at the very top, and it would break some of our efforts to modernize HTTPS. So another one that's really bad and really shouldn't because they have money. Here, NewYorkTimes.com. That's a pretty big newspaper. A lot of people read this. A lot of people trust the data that comes from New York Times. You would think their web security is pretty important, and still they get a D. So we're seeing a trend here is that overall, we really suck at web application security. And so this is data that April King, my colleague at Mozilla who runs the observatory, collects, and she publishes stats every year or twice a year. And 90%, that's a stat that she posted this week, 90% of websites scanned on the observatory get an F. 90%. Well, that's still better. A year ago, 2 years ago, it was 97%. So we're getting slowly better at it, but really, really slowly. Very few websites get an A+. That's not easy, so fine. Maybe you shouldn't be aiming for A+, but you could at least get a B. And I'll talk about what it takes to actually get there. So does this matter? That's just grades, right? Do we care, after all, to get an A+ on our website? Like, we're here to run a business, not to get a good grade on some random Mozilla website, right? Well, this is data that comes from BugCrowd. And BugCrowd, as you may know, provides a platform to operate your bug bounty, right? And they have a lot of customers. They run over 600 programs, so that's 600 corporations that uses BugCrowd to offer bounties on their websites for their web application security. And that's the data for last year. They paid out more than $6 million to bug bounty researchers who found actual vulnerabilities on their customers' websites. Right? So those issues are issues that thankfully were not exploited for any sort of malicious activity, but were reported to BugCrowd, to the companies that run the bug bounty program, and could be fixed before they were actually exploited. I don't think Equifax has a bug bounty program, or maybe they do now, but that would probably have saved their asses. So this thing matter, right? I mean, we have one of the oldest bug bounty program at Mozilla. We run it both on what we call the client side, so for Firefox itself, and for the web application side. And we pay a ton of money every year to researchers who come to us and say, well, I found some random application bypass on some random application that you guys forgot about. And we give them a few $1,000. And it's pretty much the only way for us to keep an eye on everything that we run, because we have, I think, to date, something like 400 websites that we run day to day that people rely on. Some of them are obviously more important than others. If you're add-ons at mozilla.org and you're delivering Firefox add-ons to all the Firefox users, security is pretty important. And then we have stuff like, is Windows XP dead yet.com, right? I mean, that's just one page with a dashboard on it. No one cares, but it still counts as a website. The problem we have, and that's a problem we faced at Mozilla, where we tried to be pretty good at web app security, and everybody else faces as well, including Equifax, and I'm going to beat on them quite a bit because I don't like them, is that modern web applications are ridiculously complex. And this is a funny tweet that was posted a couple months ago. Here we see a React engineer deploying a contact form. You've seen those, right? I mean, you have your dev team coming to you saying, hey, I'm going to push that Node.js application on our AWS account next week. Could you do a quick review? And you open it, it's like a gazillion dependencies and 4,000 lines of code. Like, what does this thing do? Oh, it's a dashboard for the finance department. I'm like, what? How am I supposed to review this thing? It's ridiculously complex, and it's not getting any simpler. So securing them often feels like, it's a losing battle. You can't do anything about it, but with some effort and some well-trained developers and some good practices, we can get there. And this is accounts.firefox.com, right? And we worked with these teams, so you can look at a bunch of the websites that we run, and they all get the A+ now, because we worked with them very, very closely to get content security policy in place, to improve their HTTPS, to improve their dependency management. And it's a lot of work. It takes teams of people to do it. And we learned a few things while doing that. And what we learned essentially is that you can get most of it done by following these 6 areas. These are the 6 areas that really matter to your web application security today. And I'm going to talk about each one of these. So it's going to be a fun 40 minutes. Some of that stuff is old, and I'm hoping that probably a third of the content here will not be news to you. Hoping, because I know that web application security is hard, and our heads are just, not big enough to keep it all in one place. So it's possible you learn a bunch of stuff. So let's start with content injection. And here I'm talking about cross-site scripting attacks, XSS. So that's pretty much a #1 attack vector for modern and old web applications. Pretty much since the SAMI worm, and that was in 2005. And who remembers the SAMI worm? So I'm going to re-explain what it is again. So in 2005, this researcher, that's a journalist, it's not the guy who found it, but I forget his name. Yes. And what he found is that you could inject a little chunk of JavaScript on the comment of a MySpace page. And when someone else with a MySpace account will visit that page, the JavaScript would execute in their browser, would have access to their session, and could post itself to their own page, therefore replicating itself to the page of the victim. And that was quite a little fun experiment. Really, the researcher didn't try to make any money out of this or anything, but that blew up out of proportion. And within just a few hours, it had replicated itself all over MySpace and taken over hundreds of thousands of pages. And obviously, everybody freaked out. That was just a very simple cross-site scripting attack. And we know about this. We knew about it before 2005, but since 2005, we know it's an actual problem. So basically, a cross-site scripting attack is a security exploit which allows an attacker to inject content into, inject client-side code into a website that gets executed on the victim's computer and bypasses all the access controls and can be used to impersonate them, etc., etc. That's from MDN, Mozilla Developer Network webpage. That has a good page on this. And if you've never seen one, this is basically what it looks like. That little snippet of code at the top that just injects text JavaScript, and what's between the braces here is your JavaScript code. And here it's an alert XSS that will print the string XSS whenever it's executed. You put that, you inject that into your page, and you'll have that little alert pop-up from JavaScript show up. Everybody knows this. We've seen it a million times when we test an XSS on a new page. That's the string everybody uses. So this is fairly standard stuff. So obviously, because we all know about this, it's fixed, right? This is bug bounty data from 2016 and 2017 at Mozilla. Categorized by type of vulnerability: application logic, disclosure, impersonation, CSRF, application misconfiguration, authentication, etc., etc. The one on the left is XSS. It is about 10 times more prevalent across our application than any other type of vulnerability. We know about it. This is taken 11 years, 12 years after the SAMI worm, and we still suck at it. So the remedy here, and the reason we push so much on content security policy, is because by setting this HTTP header on your web applications, you're telling the browser to not execute any sort of inline JavaScript. So if someone injects JavaScript into the comment of a page, and it's not part of a loaded script that's part of the application or something like that, the browser will say, nope, not running this, right? So obviously this policy here is the simplest possible version of a content security policy. And if you have a 10-year-old PHP application that loads code all over the place and has inline styles and inline scripts and everything, it's going to be a bit more work to get your CSP to work. But to give you an example, we used to have probably 1 or 2 XSS vulnerabilities a month on addons.mozilla.org. We invested a lot of time on putting CSP in place, and I don't think we've had a single XSS since. That was a year and a half ago. We used to pay money for these bounties. We used to have developers have to go fix their code. They used to have to track down all of the possible injection vectors. Now we just put CSP in place, and we know it's an old app, and we could probably do better, and we use sanitation frameworks and whatnot. But CSP really, really helped us kill that attack vector entirely. If you're a bit of a developer, this is basically how you put it in a Go application. I like coding in Go. You could do the same thing in Java, PHP, Python, whatever. But essentially, you have your middleware that handles HTTP responses, and you inject a response header with content security policy and the string that represents your policy. So default SRC star and object source none. And I'm not going to get into the details of what the keywords inside of a CSP mean, because that will take the whole 40 minutes. But what you should know is this. If you're starting a new project, or if your dev team is starting a new project, have them use this policy, just as a starting point, and add stuff to it as they implement more features. And basically, it will not add any work to them. It will not add any more pressure on their development pipeline. But it will add a whole lot of protection to their web application when they ship it. So do it from the start. It's a lot easier. Oh, one thing that is worth noting is that CSP does not get cached, so you need to return it with every HTTP response. Right? It's not like HSTS or the other things that get cached in the browser. CSP must be returned all the time. So, accepting user-generated content. Hello, Cartman. Yelp critic. So, if you run an application, a website, a web service that accepts user content, any type of user content, could be just comment on a blog, could be images that they can upload in their profile, it could be, I don't know, maybe you have a healthcare portal and you accept invoices in PDF format, whatever. What you need to know is that pretty much any sort of file format or input format can be used to inject malicious content. If you think you can sanitize a JPEG image sufficiently, then go look at all of the JPEG injections that were published over the years. If you accept images in SVG format, well, that's great, because SVG is a scripting language. So you can pretty much put everything you want in an SVG image. It's really, really hard, really hard to accept user content and reflect it on your main domain securely. It's almost impossible to do. So that's basically the takeaway here. Do not reflect content on your main domain. What that means is that if you accept an image from your users for their profile page, when you return that image, if it is served from your main domain, example.com, where everything else is, and you have your sessions cookies on example.com and everything, and that image has a malicious payload in it, then it can access everything that's on example.com, including session cookies, local storage, everything. The security of a web application depends on the security of its main origin. So if it's example.com and your cookies are there, anything that runs inside example.com can compromise that security. So the way we do this is every time we accept user content, and we know we're going to have to display it somehow, then we put it on a separate domain. And you might have seen Facebook usercontent.com, Twitter usercontent.com, these sort of domains that are not twitter.com or facebook.com. And what they do is they serve the image to the main site, and the site will load it as an iframe or as an external resource. And by doing so, the browser will say, well, fine, I'm loading all of that content from all over the place, but it doesn't have access to anything that belongs to the main origin. It doesn't have access to session cookies, it doesn't have access to local storage, none of that. So the important part here is, if you have a commenting system that you're hosting yourself, for example, have it served through a separate domain. Load it from an iframe into your main domain, and you won't have to worry about injections. That's actually really, really hard to implement. Like, that takes weeks of work with dev teams, because you need to catch that early. If you have to go back to an application before it goes to prod to tell them, hey, all of your user-generated content will have to go to a separate domain, they're going to freak out at you. Talking from experience here, because we've done that, and they don't like it. But it is pretty much the only way. Yeah, I mean, Facebook uses fbcdn.net. That's, yeah, basically how everyone does it. There's no other way to sanitize user content. So speaking of cookies, and that's interesting. When I learned web application security a decade and a half ago, cookies were important, and people were talking a lot about cookie security. And then we kind of stopped talking about cookie security and assumed, yeah, you know, everything's okay. And people don't really talk about cookie security so much anymore, because we assume it's secure. And then I joined Mozilla. And I realized there were like tons of people still working in the browser on cookie security. It was still a problem, and we were still seeing a lot of issues on it. So what are the issues? The main one is people store cookies, session cookies, for example, for their web application, completely in security. So they will let, for example, the cookies be read by JavaScript. Why? A session cookie, if you think about it, is really just that little random string the browser is going to send back every time it sends a request to say, hey, I'm still authenticated. But JavaScript on the page doesn't need to access that. Why would it manipulate the session cookie? There's no reason for that. It's really between the browser and the server. So why let your session cookie be manipulated from JavaScript? No reason. So set HTTP only on your session cookies, and the browser will say, fine, it's HTTP only, JavaScript cannot touch it. Don't send them in clear text. So everything should be HTTPS nowadays. But if it isn't, at least make sure your session cookies have the secure flag on it, so that the browser will only send them back over HTTPS, not HTTP. Expire them. You don't want someone to manage to get an XSS on your users, steal a session cookie, and be able to still use it a year from now. Like, that's ridiculous. Expire your session cookies, renew them regularly. You don't need to do it every 30 seconds, but at least have a reasonable expiration here. And the interesting one that we're going to dig into a little bit more is use a same site attribute. So wait, what's same site? Never heard of that one. So same site. Who knows what a CSRF attack is? Yeah, this is going to be fun. So same site prevents CSRF attacks. And I'm going to explain how that works. So you have your browser here. And the browser accesses facebook.com every once in a while. User is authenticated, user has a session cookie, and everything's great. And then the browser goes to badside.net, right? Doesn't really know it's a malicious site. Maybe it's a legitimate site that got hacked, right? And badside.net will have in its HTML an image, essentially, that points to facebook.com/delete/image/2. The browser says, okay, fine, I need to send a GET request to that URL. So sends a GET request to facebook.com. What the browser doesn't know is that sending a GET request to that URL actually deletes image2. So badside.net forced the browser to delete an image on facebook.com. That's a cross-site request forgery. Yeah, I like your look. It's like, what? How is that even possible? Well, that's how the web works. And the funny thing about this is that badside.net tells the browser to send the request. The browser is like, oh, I have to send a request to facebook.com. Let me also add all of my session cookies to that request because, it's a request to facebook.com. So you're sending an authenticated request that was triggered by a third-party site. Cross-site request forgery. And this is where same-site cookies become interesting because you can set on your session cookie the same-site attribute and say same-site equals strict. And when you do that, the browser will only send the session cookies if the request comes from facebook.com. If it goes on badside.net and badside.net says, hey, send a request to Facebook, the browser will say, sure I will, but I cannot send those cookies because you're badside.net asking me to send a request. And so I'm going to exclude all of the stuff that's protected by same site. So it's a bit tricky, but it's very important. And if you talk to your web devs and you ask them, how do you prevent CSRF today? They're probably going to tell you, we trust the web framework that we use, Django, Flask, whatever you use, Cake PHP or whatnot. Is that still a thing? I don't know. I haven't done PHP in 10 years. People laughing probably means yes. Yes, that's what runs our production. And those web frameworks usually implement CSRF tokens. CSRF tokens are complicated. They require us to do HMAX. They're a pain in the ass to deploy. People mess them up all the time. And SameSite essentially is a better way to do CSRF tokens. So you're a little bit on the bleeding edge of things here because SameSite is not deployed everywhere. But it's something to keep an eye on next time you're asked to review a web app that has CSRF problem. All right, that was tough. Let's do something a little more fun. Who knows about haveibeenpwned.com? Yeah, you won. One of my favorite sites in the world. So, great site. You should check it regularly. Troy Hunt is a fantastic person. He has been doing a whole lot of work, just collecting hacked accounts and putting that for free on the public internet. And he's just really helpful when it comes to understanding exactly how widespread account theft is. And what we've learned from Have I Been Pwned is that collecting username and passwords from your users and storing them in your database is a terrible idea. You're going to fuck it up. That's for sure. You're going to fuck it up at some point. Let me tell you a story. A few years ago, Mozilla Developer Network, MDN, is a Django application, right? And because we're Mozilla, everything we do is open source. And in order to help contributors who didn't have LDAP accounts and whatnot participate in the development of MDN, we used to give them a sanitized dump of the database. I'm going to give you 5 seconds to figure out what happens next. The sanitization job didn't work well. And one day we gave them an unsanitized dump of the database with a bunch of password hashes. So we're like, what? Why do we have 50,000 password hashes on the internet? So that was sad. That was a bad week for me. We stopped publishing that database dump, and we warned everybody to change their passwords and make sure that those passwords were not reused on other sites. But basically, we learned that we probably shouldn't ask our web application developers to store passwords, because those databases are going to leak at some point. So now the questions we ask most of the time when we do risk assessments for new projects is, what happens when the database ends up on Twitter? They always say, why the hell would we put the database on Twitter? It's like, well, it's not exactly up to you. It's just going to end up on Twitter at some point. So the best way to do this is essentially to let somebody else authenticate users for you. There are largely enough authentication IDC providers out there that you can just pick the one you like. Google, Microsoft, Yahoo, PayPal, GitHub, Amazon, they all provide identities. And what is really, really good about using those is that, first of all, for you, you don't have to store passwords anymore. You don't have to spend a whole week figuring out which hash function and which size of salt is best suited to that new 2018 Node.js application you're building. Just connect to an identity provider and you won't have any password in your database. But the other thing is, you allow your users to use two-factor authentication. And I don't know if you've tried implementing 2FA in your web app and managing tokens and managing TOTP or U2F or whatnot. It's really hard. We're doing it right now for Firefox accounts, and we're working through all of the failure scenario. And the one that is the most difficult for us to implement is, how do we deal with users who just lose their tokens and want to regain access to their account? You need a support team for that. And Google and Microsoft and Facebook, they have support teams who can answer user requests and authenticate them with whatever, their driver license or whatnot. We don't have that. So it's really, really hard to do it yourself. So what's going to happen is you support username and password authentication, and you'll never support 2FA, which is a terrible idea. The other thing is fraud detection is really hard. And I was at the Enigma conference last month, where the folks that run the account management system at Google were talking about protecting user accounts. And the amount of energy and engineering and just pure money that they invest into fraud detection is ridiculous. It's probably your entire security budget. So you're not going to do it as well as they do. It's better to let them do it. And finally, users, they already have too many passwords. I saw a little cartoon on the internet the other day. There was a surgeon opening someone's skull saying, we need to release the pressure on this person's brain. I'm going to remove 24 passwords. And it's true. Like, we all have files with dozens of passwords from websites we haven't connected to in the last 3 years, but we need to keep it around in case we need it. It's really hard to do. So identity providers solve that problem, and you should use them. All right. Switching gear again. One of my favorite topics, dependency management. Equifax. you probably know how Equifax got hacked, but just to remind everybody here, they were hosting a web application open to the internet that had a vulnerable version of Apache Struts. Apache Struts, well-used framework for any sort of Java web apps. And they had forgot to patch it. So they had an old version of it, and the attackers got in, used the publicly available exploit, probably, for it. Yes?
What was the vulnerability?
No idea. I forget. I don't do Java, so I just looked at exactly what the issue was, basically, but I didn't look into the details of how they got in. But if you look Equifax Apache Struts, you'll find the entire write-up of what the issue was and probably how it was exploited. But basically what the important part is that they had a dependency code that they had not written themselves that was imported in their web application, and that was Apache Struts. And they had not updated that dependency to the latest version. Now, probably 90% of the code that we use in any sort of modern web application comes from third parties today. The joke about the web devs who are shipping a contact form in React, well, really the majority of that code is framework. Whether it's the React framework or any sort of JavaScript dependencies that gets imported. Like if you look at any sort of modern web app, let's say Node.js, for example, we'll have a package.json file. Will contain probably 5 dependencies in there. And you think, oh, that's just 5 dependencies, great. But you need to expand that tree. Because those dependencies have dependencies that have dependencies. And when you do the entire shrink wrap operation of flattening that into the actual list of dependencies that are used, it's going to be hundreds of them. This email, I don't know if you can read it, but I'll read it for you. It was sent to me by a developer of Firefox accounts 3 days ago. Hello all, a malicious package was published to NPM called Conventional Changelog 1.2.0 on February 12th. The module will mine cryptocurrency when invoked from required context. We use this module in many of our repositories. Now, mind you, he's talking about accounts.firefox.com, the stuff that people logs into to access their accounts, right? So I'm freaking out. Server environments should not be affected by this NPM issue. I'm no longer freaking out. We use NPM shrink wrap and pin versions of packages. Good. However, John is double checking to make sure everything is okay, etc. We got that email, and I'm glad because one of our dev actually sent us an email saying, hey, we have a package that is potentially vulnerable that you probably use all over the place. Now, these guys are more paranoid about security than I am because they know they run an accounting system, user accounting system. So they're pretty security focused. But we have another probably 50 or 60 Node.js applications that may be using that dependency, and we have no idea if they're vulnerable, if they have a pin version, or if they're currently mining cryptocurrencies on production hardware. So one of the guys in my team actually wrote some scripts, and thankfully everything we write is on GitHub. So we went to all of our GitHub organizations and verified that we don't use that vulnerable version of the package. But that's something we have to do regularly. I think last year, what was he saying? I think we had 5 fraudulent NPM packages last year alone, and that's just for Node.js. And we have Python applications. You can look at how Go works, etc., etc. It's really difficult. So you need tooling in your web application. This is a dashboard that's created by requires.io. That's for Python application. And will essentially run against your source code and look at your dependencies and tell you if some of them are known to be vulnerable. And it will alert you. There are other services that do this as well. Node.js has greenkeeper.io that actually just sends you a pull request with the updated version. You just have to let your CI environment run, merge it, and you're good to go. We use pyup.io a lot. Sneak.io is a new service. If you do Java, it supports Maven. If you do Ruby, it supports RubyGem, pip, and NPM. So that's another one. I think it's still free for open source projects. Another one to look into. Dependency management, some call it securing the supply chain. You'll find it in the different names, but it's something a lot of people are worried about nowadays. The slides are online, by the way. If you just look at my Twitter account, I just tweeted them. All right, let's talk about HTTPS a bit. This is badssl.com is a site that just has bad SSL all over the place on purpose so we can test things. HTTPS is not just important because it shows you a little pretty green lock. Nowadays it's important because any sort of complex web application feature that your developer wants to use will require HTTPS. The browsers are actually, we're disabling a whole bunch of JavaScript features in Firefox, and the Chrome team is doing the same thing if it's not on HTTPS. There are a lot of stuff you can't do anymore. So you need to be able to set up HTTPS all over the place, everywhere. This example here is an alert message that Firefox displays when a user enters their password, so it's a password field in a form, on a page that isn't HTTPS. And it would actually tell the user, this connection is not secure, logins entered here could be compromised. When we deployed this last year, we had application developers and website owners scream at us because we're freaking out their users, because we're harming their businesses, and claiming that their websites were insecure when in fact they were perfectly secure because all of their servers were secure and everything. And like, how you're sending passwords in clear text on the internet? What the hell are you even arguing about? But we did have people who did not understand what was going on here. So it is critically important that we make HTTPS the default. Make it really easy, and I think this is something that security team probably understand better and can help a lot with. Make it really easy for any developer to get an HTTPS certificate on their test environment, on their staging environment, pre-production, production, whatever. Make it trivial. And the way you can do that is obviously you can automate it with Let's Encrypt. So I'm not going to get into the details of this because you all know what Let's Encrypt is and what it does. Basically run a script on your machine and it will go get a certificate for you, renew it automatically. Fantastic. You can make that a little more complicated if you're running in AWS, Google Cloud, Azure. You can use your DNS if you don't want to have your server be on the public internet. You can have a server that is behind VPN, not accessible from the public internet, and can still get a Let's Encrypt certificate. Because the challenge doesn't require you to open your web server to the internet. You can do the challenge for the certificate using your DNS records. So you can do a whole lot of stuff with automation and Let's Encrypt for your test environment, your dev environment, or stuff that you don't want to expose to the public internet. And once you have HTTPS, you should test it. So again, we're back on the observatory. There's a tab on that page that lets you test the quality of your HTTPS with the TLS observatory. And if you want a good configuration to run on your server, you can go to our configuration generator. There's config sample for Apache, Nginx, LightD, if anyone still uses that, HAProxy, AWS LBs, etc., etc. It's just copy paste at that point. All right, so I fried everyone's brains with all of the fancy new stuff. Let's talk about some old stuff a little bit. And I think everyone here will be familiar, hopefully will be familiar with the basics of testing your application. And I'm going to talk a little bit about the benefits and drawbacks of these four approaches. The first one, of course, web application vulnerability scanning. So I'm fortunate enough to have the lead developer of Zap in my team, Simon Bennett. So we do use Zap quite a bit. And obviously, we get the benefit of the entire OWASP ecosystem. So it's a great tool. But there are other tools that Zap, other problems that Zap doesn't solve. And I'm going to talk a bit about fuzzing and static code analysis, but also relying on external researchers, because I think that's very important. So Zap, if you don't know it, it's a GUI. It can be run on the command line, but it's an application that will crawl your website and look at all of the pages and find issues with it. It's really, really good for more traditional applications. It's not as good with the new stuff. For example, React uses a thing called the virtual DOM that is really hard to parse, and Zap doesn't really understand it well. But you should at least try it. It also supports web APIs. If you have a REST API and you publish in an open API document that describes your API, Zap can scan that. So there's a whole lot you can do with this. we ran a Capture the Flag challenge at our last Mozilla All Hands in December. And it was fun because we had a bunch of people come in who were used to web application security, but I never really used Zap, and discovered, me included actually, discovered a whole lot of features that I didn't know existed in Zap that really made it easier to poke at these web applications, to go discover dark corners of the app. And the app wasn't an old 20-year-old PHP app. It was a recent Node.js app called the OWASP Juice Shop. If you haven't looked at that, it's a really cool CTF, Capture the Flag application. And Zap was a really great tool to browse that application and start poking at its dark corners and find issues. And one of the things that we do a lot is we run Zap as a proxy. So we essentially tell, the browser to go through Zap to go to the target website, and Zap will inspect everything that transits through that connection. So even if you have a really modern web application or something crazy or like a super old JavaScript or Java app, and there's really no way to inspect that directly, you can still use your browser to interact with that application and Zap to inspect the content as it goes through. You can also do fancy things like fuzzing in Zap. So, for example, you're capturing a request that has an argument in the URL. You can select that argument and say, all right, replace that with a whole bunch of random UTF-8 shit and see if that blows up the app. And that's useful if you're in more of a pen testy mode where you're trying to really break your application. You can do interesting things with it. Static code analysis, I think, is more something that developers should use. It falls, in my mind, more in the category of writing good code and cleaning up your code. And the same way you will write a Python application and pass it through your unit test or pass it through Flake 8 to make sure it's well formatted and everything, it's useful to have a static code analysis look for issues in the code you wrote. So here the issue we found, this is called Bandit. It's a static code analysis tool for Python. And it looks at the source code of an application called Kinto. And it says, for example, here we're using, I don't know if we see it here, we're using the input method right here. And in Python 2, you can put Python in that variable, and it will get executed as Python code. Which is pretty cool. Username, sure, let me write a Python script as my username, and that gets run on the machine. The static code analyzer will catch this, whereas it's unlikely that Zap will try to inject a Python script inside of a username. Like it's a little more instrumented, right? You need to know what you're doing. In Python 3, this isn't an issue. They fixed the input method, but it still is one in Python 2. Static code analysis is also something that developers will understand better than security people, because you need to understand the code, you need to understand the specificities of the language you wrote the code with. So there are a lot of really fine details about how your application is built that are difficult for security folks to work through. So, but a good tool, at the very least, you should ask your dev team what they think of these tools. Run it against their application and take an hour with them and say, hey, I just run this thing and I just want to go through it with you and see if you think those are issues and if we should put this tool in our continuous integration platform to run it regularly. And maybe they'll find a whole bunch of false positives and not like it. Maybe they'll find it useful. Right? But at least you can ask them and have them participate in that process. So I mentioned DevOps. We didn't talk a lot about DevOps, but we do a lot of integration of our tests in continuous integration. What we don't want is to have to go scan production apps that have been deployed a month ago in order to find issues. So what we do is our devs will build their applications in GitHub and run all their unit tests in Circle CI or Travis CI or whatever CI they like to use. And we'll put our test code or scanning code directly in that CI environment. So every pull request will go through some amount of testing. You can do that with Zap. We have the thing where we call it the Zap baseline scan, because it really does like basic tests here. And you pull down a Docker container, Zap to Docker weekly, and you run that directly in your CI environment against an instance of your application running locally. And we'll find issues, like all of the issues we talked about now. Here we have missing X-browser XSS protection, so no content security policy, but there's an anti-CSRF token. So the stuff we talked about, how you secure your cookies, how you put your CSP in place, etc., you can test for it continuously by putting your testing tool directly in CI environments. And to close on something a little bit lighter is I really think everyone should consider opening a bug bounty program. These are the payouts that we give our researchers. And if you find a remote code execution on a critical site, so that's going to be one of the main sites that we run, you'll get $5,000. You'll get your name on the Hall of Fame and probably a published report and all that stuff. We have a lot of junior developers, junior security people who come to our bug bounty program with a very limited understanding of web application security and use the program to ramp up. So part of the cost for us is triaging all of these low quality security issues from reporters who do not have the experience yet. So sure, there's a cost, and I wouldn't start a bug bounty program. Like, for example, if you're running 50 websites and you know they're insecure and you're the only person doing security, probably don't put all of them in your scope like day one, because you're going to get so many reports that triaging them is going to kill you. But you can ramp it up slowly, putting one website at a time and make sure that you are polite to researchers and that you pay them, because they like that too. The other thing I recommend, and I gave a version of this talk to web developers at some point, and they were more interested in this, but and I know you guys will know this already, but I mean, do get external teams to review your web apps. Give them the source code. Give them. We did one. We do that regularly. This is on Firefox accounts with Cure53, a German company that does fantastic WEBAPPSEC work. We gave them the source code. They came back with a list of 20 issues nobody would have thought about. And that's really, really valuable. Obviously, costs more money, but I think it's really worth the effort. Like, sometimes, in my mind, if you're looking at your budget for the year and you have to choose between hiring a new security person or investing that amount of money into external tests, you might want to consider external tests, because you're not going to get a single pen tester who can do the same quality of work that an external firm is going to do. That's not going to work. So you might want to consider that when you build your budget. I'm going to skip on this. Don't host your stuff yourself if you can avoid it. Use Heroku, AWS, Google Cloud, etc. It's better. So some resources on this. We have a pretty big page on web application security on the Mozilla Wiki. We have a security checklist that we give to all of our teams. It's in Markdown format. So they can just copy and paste it in GitHub issues. Again, it's on the wiki. The slides are online. The closing thoughts is don't be Equifax. Stay out of the news. Secure your websites. Thank you.